And we are live. Welcome everybody to this meetup. Glad to see the first people joining. Very nice. So if you already joined, feel free to locate the chat and feel free to say hi to everybody. Maybe include the location from where you are joining. It's always interesting to see. And if you do, make sure to select to all participants before you post your message. Otherwise, only Nils and I will be able to see it, which is also cool, but not as cool as everybody. So I do see people coming in. I'll give this a few more minutes. France, nice. Hello, Nicolas. I give this a few more minutes to allow people to join before we start. Copenhagen.
Hello to Denmark.
Nice. And I see you both figured out to send to everyone. That's nice. India, Poland, London. Nice. We have a still European with some Asian people crowd today. Nice. California, cool. Yeah, make sure to select everyone before you post in the chat, because otherwise only Nils and I can see this. So maybe while we wait for maybe another minute or so, let me launch a small poll that you should be able to see. It's basically just so that Nils gets an idea for the audience. You should see the poll now. What we are basically interested in is your level of experience with Kubernetes and Vault. So if you have the time, just feel free to answer the poll, and then this should give us a good feeling of the audience today. Maybe a few housekeeping rules before we get started. So this meeting is being recorded. As you can see, we will share the recording with you tomorrow, together with all the links. I assume, Nils, you'll have some links in your presentation talking about such a technical topic.
There is a couple of things we are going to look at for sure.
Yeah. Cool. Okay, so we'll share those. We'll share the presentation with you tomorrow. Together with whatever other things Nils believes are important to get you started with Vault on Kubernetes. If you have questions during the presentation, there's two ways of providing or asking questions. One is you can either put them in the chat, which you already located, or you can put them in the Q&A section. I monitor both. Q&A section typically is better if you don't want your question to get lost. But feel free to use either chat or Q&A. And you should see the poll, right? Because I don't see any answers yet.
Yeah, some people are writing that they are not able to answer in the poll. Maybe it's not started. It says an error.
It's open. Let me try to end it and reopen it. Now it's ended. But now I'm not sure. Relaunch poll. Let's see. Relaunch. Well, if it's not working, it's not working. Now we see answers coming in. The magic of Zoom, working or not working. Cool. Glad we figured that out. All right, so I'd say let's get started. 3 minutes in. I still see people join. We're about 35 now, probably growing. Cool. So good to have you all here. I'm Christoph. I'm your host tonight. I'm super excited to have Nils with me today. It's going to be a technical introduction to Vault, I guess. I used to be an engineer, but that's a decade ago. So I'm looking forward to see whether I understand anything from what you're going to talk about. But yeah, super excited to have you here, Nils. Maybe you introduce yourself and kick this off.
Yeah. Thank you very much, Christoph, and thanks for so many people showing up. It's always great to have a big audience. Yeah, so my name is Nils Balko-Tüxen, and I'm the lead QA engineer at Humanitech. Maybe first a word about Humanitech. Humanitech is essentially an internal developer platform. So it's used by development teams to make their life easier by providing a focused view on application development, with having all dependencies included, like application configuration, Kubernetes clusters, and deployment configurations, as well as out-of-cluster resources like databases and DNS. So, but the real question is, why am I doing this webinar, right? So Hashicorp Vault is kind of the industry standard when it comes to application secrets management. And also Humanitech is using Vault under the hood to provide secrets management to their users, basically. And on top of that, I recently migrated the secrets management of our internal testing infrastructure to Vault. So overall, it was quite an interesting experience to get started with Vault. It's also quite well documented, I must say. But it's also a very complex topic overall, right? So I thought this might be a good reason to give a talk on the topic, and like I see there's more people interested in this. So yeah,
absolutely. Let us briefly look at the poll results. So if I read this right, I closed the poll. Let me share the results just to get a feeling. And I like that. I mean, I understood you have been in touch with Vault and playing with it and having to deal with it for quite a while. Now you're sharing your thoughts with the world. I really like that. So if we look at distribution, we have 2 people that say they're Kubernetes and Vault pros. So they might challenge you, Nils, on some of the things. Let's see. And then we have, it's always good. Then we have 35% that say I'm a Kubernetes pro, but have not used Vault yet. I think that's a very common thing if you start dealing with Kubernetes and then start thinking about secrets, right? And then we have about half of the audience tonight or today, from wherever you join, that just get started with both. So maybe that helps you to calibrate your presentation, Nils.
Yeah. This is really cool to see.
All right, then let's take it from there.
All right. Okay, yeah. So just to give you a brief overview of what we are going to touch on today. So first of all, I will talk a little bit about like why do we actually need application secrets management, right? After that, we'll look how we can bring Vault alive on a Kubernetes cluster via Helm, which is really very straightforward. So there's not much to show. But for some people, this might be new. So I'm going to talk about this as well. And then we will start with a very, very simple application, which is supposed to access secrets from a Vault cluster. And the application will basically take care of talking to Vault and getting those secrets itself. And then we will talk about a more complex, more configuration-heavy setup, basically, where the secrets are being injected by a Vault sidecar, and the application itself actually does not know anything about Vault at all, which is kind of nice because it keeps things open for your application development. And then last but not least, I will talk a little bit about what to watch out for, what to take care of if you want to run Vault basically in production, or in a more production setup. All right. So why do you actually need application secrets management? Yeah, so on the one hand, like you want to store your secrets securely. You want to make sure that when you're transmitting your secrets to your application, that they are transmitted securely. And what's also nice if you have application secrets management is that you're able to audit basically access to your secrets, right? So you know like which application or which account has access which secret at what point. So through this, you're also preventing unauthorized access because only authorized accounts or applications basically have access to the secrets. Then it makes it much easier to share secrets securely. So if you're in the habit, for example, to use like an instant messenger like Slack, for example, to send application secrets to your colleagues, which you obviously should not do because I mean it's a third-party tool. You basically with Vault you have the opportunity to basically share the path to a certain secret in order to let others basically through a proper authentication access those secrets as well. Yeah, with secrets management in place, there's no need of storing your secrets unencrypted or in plain text anywhere. It gets much more easy to rotate any secrets you might have because they are accessible and all in one place, basically. And also when it comes to leaked secrets, so if you have a secret which a third party had access to, it's much easier to revoke it without actually touching the application. So you can just go to your secrets management and replace the secret basically with a secure secret. So that would be that part. So then let's get started with how are we going to bring Vault to life on a Kubernetes cluster using Helm. And now it gets a little bit technical, so fasten your seatbelts. Yeah, so I'm using here the package manager called Helm, which is kind of one of the standard tools for bringing applications to life inside Kubernetes. And if you don't know ArtifactHub.io yet, it was formerly known as Helm Hub, basically. This is a place where you get essentially all your Helm charts, all the definitions for all the different open source applications you could potentially use inside Kubernetes. And here you can also find a nice managed chart from Hashicorp, so the company behind Vault themselves. They update it, they make sure that there's always the latest version available, and so on. And in order to install a Helm chart, it's essentially 3 commands. You're going to use the first one, Helm repo add, is basically adding the Hashicorp repository to your list of Helm repositories. Then you execute a Helm repo update command, which is then basically getting all the latest versions of the charts available. And then last but not least, you're using Helm install, pointing to Vault from that repository. And here in my demo setup, I'm basically using the development mode enabled. And I'm also setting, like with -n, you're basically setting the namespace you're going to install Vault to in your cluster. Just a quick look at the at Artifact Hub, basically. So what's quite nice here is you always get a nice description of all the Helm charts. You also can see like the usage, like on how to install it, like the 3 commands I just went through. And then on top of that, you can also see like the default values of those Helm charts basically here. And I mean, this is quite a long list of default values, but what I find quite nice, for example, is they have integrated basically a nice search for the YAML structure inside those default values. And then you can basically see that by default, the section server.dev is by default basically enabled false or disabled, one could say. All right. I have already Vault running and I have it already installed, so you don't have to watch me while I just execute a Helm command and wait until it's coming up. I have the possibility, so I'm already connected to my cluster. Basically, I'm using, in this example, I'm using a GKE cluster essentially, and in order to access Kubernetes, I grew a bit tired of using kubectl. I mean, it's easy and it's straightforward, but I recently switched to a tool called K9S, which is essentially just a wrapper around kubectl. If you're interested in it, you can basically take a look at k9scli.io. I think it's quite a nice and easy to use open source Kubernetes CLI tool. But let's have a quick look inside the cluster basically. Yeah, so we are already looking at the namespace Vault demo, and we can see the pods which are running here. So one being the Vault pod itself, and then on top of that, it comes by default with the Vault agent connector installation as well. So if you're looking at, for example, stateful sets which are installed inside this namespace, then you could already see that Vault is basically using a stateful set to be installed. And then if you're looking at deployments, for example, then you can see that there's the Vault agent injector deployment basically running also. So let's go back to the pods again. Once you installed Vault using Helm, you can basically look at the container output at the logs, which is also quite easy and straightforward inside K9S. And this gives you basically, since it's running in dev mode, it's already, like Vault is already unsealed, completely accessible. It prints you out the unseal key. It also prints you out the root token. Basically, this is all for development mode, and it basically says here as well, like, don't use the setup when it comes to production, basically. But this makes it really, really easy to basically try out Vault, to have all the informations available you will essentially need. I have
Sadok is asking a bit off topic, but is it also possible to integrate or to use Vault with Docker Swarm? Do you have any experience with that?
So I have not done that. I have not used a Vault in a Docker Swarm setup, but since it's running in a container, obviously you can run it also in a Swarm. Like it's also very possible to just run the Vault container or the Vault setup locally on your machine. Mm-hmm. Basically just using Docker and then
Docker desktop
basically, Docker desktop, for example. So for in those regards, you can obviously also use Docker Swarm for this. Yeah.
Okay. Cool.
All right. So what I'm going to do now, basically, since I want to show you also the UI of Vault, of this Vault instance, I'm using kubectl port forward. And here in K9S, I can just do this with Shift F, and it gives me a nice little dialog to basically activate port forwarding to this pod. And since I have port forwarding activated now to this pod, I can basically go to localhost 8200, and I basically see the UI of my Vault instance. So here, there's already the token root, which we already seen in the container logs, and then you're basically logged into Vault, into the UI, which I think it's a quite nice UI. It gives you a nice overview of all the secrets. I'm now logged in with the admin with the root token, so I can see everything which is there. I already created a secret up front, which we will look into details later, basically. So you can basically explore the secrets. You can show the secrets also to you as a JSON object and so on. So I think it's overall quite a nice overview. In terms of access modes, out of the box, it only provides token authentication. So you need to create a token, or you need to use a root token in order to access Vault. What I have already added, and I will talk about this later a little bit more, is a Kubernetes authentication basically to this Vault instance. And then on top of that, I also defined a policy, basically. I will talk a little bit more about this policy as well, like a policy to define access to a certain secret. And then on top of that, you also get a couple of like web tools in this nice web UI when you need to manage and work with secrets, basically. This can be always good to have. All right. Are there any questions about this up until now?
I haven't seen anything so far.
Okay, good. All right, then let's jump to the next topic. So now we want to use an application to actually access secrets from Vault, and I'm starting here with a very simple setup for this. So there's a definition available on the Vault docs, basically what your application needs to be capable of in order to consume secrets from Vault. So on the one hand, you need to be able to authenticate with Vault and acquire a client token. You need to be able to manage the life cycle of a token from your application. You need to be able to retrieve secrets from Vault. And you need to be able to manage the lease of any dynamic secret if you want to use this feature, basically. But these are basically the requirements Vault is putting on top of your applications. And in this example, I'm basically showing you if you actually want to teach those capabilities to your application on how this would look in a simple example, right? So I built a small demo, basically, which is available here. I can also, I can also just copy and paste this to the chat if you want to see this. And yeah, it's a very small Python application. It's a Python Flask application. I'm using a pip module called HVAC, and I believe it stands for Hashicorp Vault Agent Client or something like that. And essentially, this import basically enables me to use the capabilities of the Vault API, essentially. So if we look at this application, it basically takes 3 environment variables. So the Let me make that actually a little bit bigger. So it actually takes the Vault URL, the Vault token, and the Vault path. And this would be the path to the secrets, basically. The Vault token would be, for example, the admin token. And the Vault URL is basically, in this case, for example, my local host URL, because I'm port forwarding to the Vault instance in my cluster. Yeah, it has a small function to check for those environment variables. It provides a UI, basically, where it will return the data object of the secret it has returned. So basically in this client, the client will basically establish a connection to Vault, and it will check if the client is authenticated, essentially, with Vault. And then it will use the secrets capability of Vault to read the secrets from the path I'm providing as an environment variable. And then at the end, it basically returns this information and will expose it on the UI. So in order to get an application alive, I would be stupid if I wouldn't be using Humanitec, because it's very easy to just get this application alive and show it to you. But you've seen already the code, basically, and now it's just about basically looking at Humanitec on how this application is running and how it is accessible and how it is being configured. So when you look at Humanitec the first time, you can basically see that the application is already running. It's consisting of one workload. And if I look into the details of this workload, I can basically see the setup. So it's using a specific container, for example, a specific container image, which I already pushed to Humanitec before. It's providing me with a DNS record, and I'm using a wildcard certificate here. I will show you in a second. I need to port forward to port, or I need to define an ingress to port 5000 inside my container, because that's a standard Flask port, basically, and I didn't overwrite that. And I'm setting a couple of variables here. I put those on purpose all in plain text, but I also could put them through Humanitec in as secrets, basically, and then they wouldn't be like visible or readable at this point. But that's basically the basic setup. Like I can also do like container configurations and so on through Humanitec. I already deployed this application, and if I look at the running application, I'm also getting this URL. So it basically brings me to newapp.io and a random subdomain it's basically creating for me. And here you can see it's basically talking to my Vault. So it's getting the data. It's basically getting the secrets from the path I have been setting, which was test, and it basically gets two secrets here, so my app secret and the second secret. And just to prove to you very quickly that this is also the correct secrets, if you're now going back to the to Vault itself, and for example, we would change a secret. Let's look at it in JSON format, another secret value. I think there was a way to edit it, sorry. Create a new version. Secret value test demo, and then I save this information. Basically, I can see that this value has now changed, and if I'm refreshing, then basically I'm getting the new secret value basically in my application. So this is how that is looking. And obviously, like the only thing I did here, like there was already a token was already predefined. I just used basically the admin token. So I didn't, like I did authenticate with Vault, but I did not acquire a specific token. I did not manage the life cycle of the token here, and I just received basically retrieved the secrets from Vault in this example. Any other questions up until now? Soon we will start with a little bit more complex setup where the application actually does not know about Vault.
You don't need the admin token in a.
Yeah, I usually I would not give
variable.
the admin token to an application, right? Like,
yeah.
I mean, I think that should be clear, but yeah. But
no questions so far. So
example, cool.
Let's move to the more realistic or complex setup.
Yeah. So the next setup, yeah, this will be like for me, like getting my head around like injecting secrets via Vault Ancient sidecar was like at first I thought I understood this very clearly, but then it actually turned out to be very mind blowing. But I will show you how it's done. So for this, obviously, I did not come up with all the details to this myself, right? So I have to give credit essentially to the nice tutorials available on Hashicorp Vault, basically. And if you look at this tutorials, it's exactly describing injecting secrets into Kubernetes pods via Vault agents. And if you look into the details, it also starts from the very beginning, telling you what needs to be installed. In this example, they're actually using Minikube, so a local Kubernetes variant, and so on. So it has all the bits and pieces you basically need for this. What's important here to do, and one step I haven't talked about, is how to enable and configure basically the Kubernetes authentication, right? So after you install basically Vault into a Kubernetes cluster, the one thing you need to do is basically, if you look into this nice guide here, now it's installing the Helm chart, setting a secret, configure Kubernetes authentication. Basically, it describes that you need to go into the container with kubectl execute. And what you then need to execute in there is basically the Vault auth enable Kubernetes. And by doing this, what will appear basically inside your Vault is basically the additional authentication method, Kubernetes. In addition, so that this is actually properly working, you need to execute another command, which is called vault write, and it's basically writing this configuration. And there's a couple of like placeholder variables here, but these are all basically filled in from inside your cluster. So like the pod Vault is running in is already aware of, for example, the Kubernetes address here, for example. So this is all very straightforward up until now. The next thing you need to take care of, because your application doesn't do it, but you need to take care of defining an access policy for your secret. So far in my last setup, we did not need an access policy, an explicit one, because I was just using an admin token, and that made it very easy because I had access to all the secrets basically. But defining an access policy in this example is quite important. And in order to do that, it's just another command from inside the container basically, and you're defining the path and you're defining the capabilities essentially, what capabilities you have with this access policy. Like there's a couple of things basically available. Like if you look at the policy syntax, for example, you can, for example, just define like read capabilities, but there's a lot of like other things. Like if you would define, for example, like secrets and then just put in an asterisk or wildcard, then you would have access to all the secrets. Like this would be kind of the same as the admin token, for example, like defining create, read, update, delete, list, and so
on. We have two questions.
Yeah.
So Sergu is asking, only one Kubernetes cluster can be configured at a time? Question mark.
The question, like, I mean, it depends in what regards. Like you can run like we come to this a little bit later when we basically talk about running a Vault in production, where you would have, cool. For example, like a high availability mode, for example, right? So there can be like more things defined.
Okay, yeah, let's move with that. Nicholas is asking, what's the difference to set up Vault in your app rather than provide secrets through Kubernetes Volume or Envars? Is there a best way?
Yeah, so it's a matter on how you want to deal with it, right? So I think like adding capabilities to your app can be quite straightforward if you have like kind of like all the same boilerplate code basically, and you use all the same language throughout your development organization and so on. It could be quite straightforward to do this. But then on the other hand, it's also nice if your code doesn't need to know basically about your secrets management, right? And it's completely agnostic from that. That also makes it quite easy to switch things around if you want to switch to a different kind of secrets management. And it also basically does not require all the app developers to know about how to deal with Vault essentially, because it's more like a configuration topic. So I think the second option, especially if you're running on Kubernetes, is in my option the better way of doing this or using this.
Okay.
Cool. Yeah, so we talked about enabling and configure Kubernetes authentication. We added an access policy. Let me quickly show you the access policy I have here. For example, you can nicely see them on the UI. Access policy is called My App, and it basically gives read access to just the pass test, essentially, which are the secrets we already have seen. Yeah, and then on top of that, and now it gets, I think, quite interesting. You need to create a Vault authentication role and bind it to a KNS service account, as well as to the access policy. How this is described here, basically, I mean, they talk about defining a Kubernetes service account, but that's like very straightforward, like a kubectl create, and then it's done. In my example, I was even quite lazy, and I'm just using the default service account, which in a production setup you might not want to use, but you can just define like any service account. And then it's a matter of creating, let me quickly get to this, creating this just one second, creating this role basically. So I already have the role basically created. So it's inside Kubernetes and it's called My App Role. And in this app role, you basically define like the service account name, default, and then also basically to which namespace it's bound. So you always have to define both properties to have this as secure as possible, that it should be only this one service account from one namespace essentially, which should be then able to access the following policy called My App essentially. And then the only thing you need to add to your applications is actually a couple of annotations to the deployment of your application. And basically, this is the list of annotations I'm going through. I'm going for my example application. And basically, what you're adding here to the Kubernetes deployment object is basically annotations for the Vault agent injector to pick up on. So basically, you define agent inject true, and this will trigger the injector to basically start and add sidecast to your deployment. Then you basically pass on the app role, which is connected to the service account and to the policy. Then you define a path you want to get basically. And then one thing I decided here, I decided for those Vault annotations and for the agent injector to basically create a file inside my pod, which is then containing a rendered list of my secrets. So basically, I'm going here for key and value pairs of the secrets I'm getting from this path. and I'm just adding export in front of it. So basically, I'm like a shell file. I can then execute this on startup to source basically those key value pairs, and therefore they are then available inside my application environment. I will demo this to you because this is what it is about, right? So let's quickly jump back to Humanitech, and inside Humanitech, I have a second application basically set up, and this application is extremely simple, and to make sure that it is actually extremely simple, I'm just using an Alpine Linux image called BusyBox. It has just some internal tools for debugging basically installed, so there's no big application code, and it definitely does not know anything about Vault basically running next to it. But what I'm adding here is I'm adding a startup override. So I'm executing the command source, and then basically the file vault secrets config, and then basically sending the container into the loop, so it's basically available and it doesn't start. Yes, so I'm just seeing this question from Nikolai, actually, Nicholas on the side, and he is asking if it's possible to inject the secrets somewhere else in the environment. And actually, yes, this is absolutely possible. Like one way is for example, like using a file. There's other ways of using a volume basically where you can put secrets in, but there's also ways to for example use a config map or a secrets object inside Kubernetes. So there's a couple of ways in doing this basically. Yeah. So what I also want to do quickly here is I want to show you on how this application is coming alive. So I can easily see like the namespace of this application is Vault demo app, and I will quickly use K9S again, and I will switch to this namespace, which is Vault demo app. And currently nothing, basically like no deployment, no pods, nothing is running in this namespace. And I will quickly trigger the deployment from Humanitech, so we can basically, yeah, redeploying the last version, so we can basically see things coming to life, which I think is quite interesting. So Humanitech is now basically triggering this deployment. It's also like issuing any resources you might have connected to this application. So if there would be like dependencies on a database, on a DNS record, and so on. It's starting also out of the box with a fluent bit sidecar, so that we are able to see things. And I can already see that here is a BusyBox container is started. And if I look at this BusyBox container, it's basically, it did not just start the BusyBox container itself, but it also added 2 sidecars, right? And we already talked about the Vault sidecar. So the Vault agent init is already done. So now all are basically completed. And if you look into the container logs, for example, of the Vault agent init, then we can see basically what's happening. So it's doing the authentication, it's starting some sort of sync server, it's writing a token, which you could also use basically in your application, right? So you could use the injector to basically get a valid token for your authentication based on the service account, and then inject this token into your application, and then you can basically use this token to authenticate from your application. But this again would require like code from your application. And then here it's basically also talking about rendering the secrets to this path, which is then picked up by the application. And also to just quickly show you the deployment. If we look at the YAML basically of this deployment, just scrolling down a bit, here you can basically see the annotations which have been added to the deployment, right? So it's exactly the same which have been there before, which are causing then the injector sidecar to be added. And it's not reacting. And if we look at the pods again, and we are looking at the BusyBox container, and actually looking at the output of the BusyBox container, then we can see, in addition to all other kind of environment variables which are being set, basically, it's also printing out the my app secret, and then also the second secret down here. And it's also the updated version we added actually quite recently. So this application has now access to the secrets and can essentially use that. Nice. Since I believe this is a little bit complex to understand because there's a lot of things happening also at the same time, and I just want to go step by step through the things which just happened here in order for you to understand what's happening. I just see there's another question actually from Juan. Can you access a secret from multiple different selected namespaces? So this is something you could define through the not through the policies, but through the roles, basically, right? So you would need to set up roles for each namespace in order to make like the same secret, for example, available to certain namespaces. So this is definitely possible in the setup. All right, just very quickly about this example. So on pod start, basically the application pod is starting, and the application pod has the Vault injector annotations added to its deployment, right? What then is happening due to the Vault injector annotations, the Vault agent injector inside the Vault namespace gets basically triggered, and it then injects sidecar containers to the deployment of the application pod. So these sidecar containers come up and they basically try talking to Vault, and they use basically the Kubernetes authentication which has been configured. The Vault sidecar container is also submitting the Kubernetes service account running in the application namespace, and this Kubernetes service account gets then matched to the role defined in Vault. This role defined in Vault knows about the secret access policy. And then thanks to the secret access policy, it's able to access the application secrets. So the application secrets are then passed on to the Vault sidecar container. The Vault sidecar container can then finally inject those secrets into the application pod, and your container running in this application pod containing your application can finally access those secrets. So I think it's quite a lot, and kind of felt a little bit mind-blowing, at least for me, when I started to understand this. All right. Any more questions?
We have one more question.
Oh yeah,
from Sadok. It's basically two questions in one, so it's a bit tricky.
Right.
So how granular is it to set the capability per service? So each service has a different access permission for the same secret?
So yeah, I mean, it depends on how you want to set this up. Like I have seen setups where you basically have each service running in the same namespace has its own service account to access then different secrets. Like this is definitely possible. If you want to make sure that basically like each kind of container or each kind of part of your application or each microservice is kind of contained by itself, and it should not be possible if somebody gets access to this container, they should not be possible to basically get further access to other containers. So for this, it could be recommended, I would say, to actually like define one service account per microservice running in a namespace, and then based on those services, then connect different policies to different sets of secrets. But there could be also reasons why you would set it up in different ways if you're, for example, like reusing certain secrets by certain services, which is also not unusual, right? So plenty
as
of
always,
possibilities.
it depends, but
Yes.
there's a lot of different possibilities. Second question, is there any way to automate this configuration besides running all commands manually?
Yes, Yes, there's definitely ways to automate it. Vault has a very extensive documentation for the API, but I basically for this example I followed basically this guide, which I think is really good in explaining this. But on top of that, if you're looking into the Vault docs, there's a very extensive API documentation, and all those capabilities are also very much available through the API.
Okay, so can be automated via the API.
Yes. Yeah.
Nicholas is asking, what roles should the service account have? In example from the doc, it didn't have any role permission set up. Does it mean the service account don't need any roles attached?
Yeah, so the idea is like the service account doesn't know anything about it doesn't know anything about Vault, it doesn't know anything about the secrets, and it doesn't know anything about the roles. It's the whole matching is essentially
the joy of home office.
Yeah. Sorry about that.
All good, no worries, Nils.
Yeah. So everything is basically defined in the application role, essentially, right? So the application role is doing the final mapping between the service account and the policy, and it's also verifying the namespace on top.
Okay, cool. Maybe, I mean, these were the questions for now. Pretty sure there might be more, but maybe let's talk a bit about how to run this in production, because I think the setup you run is probably not 100% perfect for production, right?
Yeah. So far, I think I'm hoping I was able to give you at least a good idea on what is being involved if you want to get into application secrets management with Vault, right? So we talked a lot about like how to set this up for certain kinds of applications and what kind of levels you can basically take in terms of like how much capabilities do you teach to your application in comparison to how much configuration do you want to deal with in order to not give those capabilities to your application, right? All right, but let's continue with running Vault in production. Essentially, here there's another nice page and really good documentation where Vault themselves are giving lots of hints on how to operate Vault in a production setup. So there's a lot of best practices they are essentially describing, and it's quite extensive, and I highly recommend to go through this if you want to use Vault in a production setup. But in general, it's first of all, it's about hardening your Vault production configuration. Like first of all, you don't use development mode, and if you're not using development mode, the development mode has one tricky thing, for example, to deal with is once you're for example, restarting the pod, all your configurations are gone, because like in development mode, there's no persistent storage, right? So obviously in a production setup, you would need to add persistent storage basically to your Vault setup, and you need to decide like what kind of persistent storage you want to use for this. Then on top of this, there is those like the root token you need to define obviously yourself, and then also the unsealed secrets, because when you start Vault in a production setup, it basically out of the box it's sealed and you can't do anything with it, and you basically need to unseal it, and there's also automation available to have this unsealing process of a restarted Vault instance basically happening automatically for you. Then on top of that, there's options to run Vault in a high availability mode. You can basically decide like how many nodes of Vault you basically want to run, which you want to run next to each other, and ensuring basically a high availability. And then when it comes to defining those like tokens, policies, entities, you can also group those entities and policies On top of that, there's also a way to define like namespaces inside Vault for certain like groups of secrets and so on. What's important here to always approach this with the principle of least privileges basically in mind. So by this I mean that you basically define the smallest need of your application. So if you have one application and it needs to access these kind of secrets, then it should only be allowed to read like this list of secrets and nothing else basically. And this way you're making sure that if like one part of your structure of your application, or if something is compromised, that's always only a small part of all of it basically, right? So this is why you approach this with least privileges in mind. And then on top of that, like there's nice options in Vault as well to auto rotate keys and secrets basically, right? So that you're not always using the same secrets and work with static secrets, but have basically a more dynamic setup and basically auto rotate those keys and secrets in as well. Yeah. That's basically it. Do you have questions about running Vault in production? I'm pretty sure you have questions about running Vault in production because it's a big topic, but I honestly, I probably have to refer you to the documentation here.
Let's see. Cool. First of all, thanks, Nils. Great introduction to these two ways of using Vault. Yeah, the floor for questions is open. So if you have questions, then feel free to drop them. So Nicholas has another question. So are the secrets stored encrypted on storage? Do you think Vault would be a good fit for an internal password manager?
Yeah, this is something I'm not 100% sure about. Like I mean, the secrets are stored and encrypted on storage. Like this is something obviously, like this is something Vault will take care of. Like if you're adding persistent storage basically to Vault, then Vault will make sure that those secrets stored in this persistent storage and also the configuration is encrypted. So this is definitely part of the package. If you should use Vault as an internal password manager, like if you hate yourself. No, I mean, it's like I think there's easier ways for internal password managers basically and more usable ways. Like I think Vault has a very good fit when it comes to application secrets and basically obtaining secrets programmatically. Right, and for this, Vault is definitely the right fit, but I would not necessarily use it as an internal password manager. I think there's better products for this out there, at least from my point of view and currently.
Mm-hmm.
Cool. Yeah, then I will already say thank you very much for attending. Like this was absolutely great, and thanks for the great questions. Always good to have some engagement here. Yeah, last but not least, I also would like to highlight to you that Humanitech as an application management and deployment tooling also provides secret management basically out of the box. So this is something you could also try out if you want to, and it's a bit more straightforward and readable than it might be involved. But yeah.
We'll include a link to the free trial in the follow-up email. Nils, thank you so much. That was great. I think it's always fun to bring things you dealt with over the last weeks to a broader audience. I think there's the saying, you understood something if you can also teach it to others. So I think you did a very good job here. Thank you so much. Thanks everybody for attending. We'll send out the recording and the presentation tomorrow. Yeah, have fun with testing Vault yourself.
Absolutely, yeah. Enjoy.
All right. Goodbye.
See you. Bye-bye.